Hello all, my name is Ashutosh Rastogi. I'm a teacher by profession. My mission is to impart quality education for all. For that purpose, I'm creating these videos. If you appreciate my work, then please do like my video and subscribe my channel so that I could get the motivation to prepare more videos.
Anyways, today in this particular lecture, we will going to perform the analysis of composite information signal in the amplitude modulated systems. We will also going to discuss some of the numerical examples associated with the same thing. So these are the outlines. We're going to start up with the introduction where we will briefly describe about whatever we have learned in our earlier lecture. Then we're going to discuss about the modulation by a complex information signal, which is nothing but your multitonic signal. Since in real life, the signal that we have to deal with is a composite signal, that is they are multitonic signal. They will going to contain multiple frequency component. Then we're going to discuss about the frequency spectrum of this composite information signal. Then we're going to calculate the power of that complex information signal, and finally we're going to discuss one or two numerical problems related to that. So in our last lecture we have discussed the power and the current value calculation in the single tone information signal. Single tone means the information signal will only going to contain a single frequency component. Whereas in the real world, the modulating signal or the message signal is often a complex waveform, or we could say that it is a composite signal which is made up of multiple frequency signal. Or we could say that these are the sine waves with different amplitudes and different frequencies. So in this particular lecture, we will analyze the composite signal, that is your multitonic signal, and find out how the modulation index and power calculation takes place, since our last exercises only considered about your single tone message signals. So in our earlier discussion, we have evaluated the general expression for single tone AM signal as this ST is your modulated waveform, that is equal to Vc times of cos of 2 pi FCT plus Vc times of MA upon 2 times of cos of 2 pi Fc plus FMT and plus cos of 2 pi Fc minus FMT. This particular factor is for your upper sideband and this is for your lower sideband. Here CT is your carrier signal, which has been given as Vc times of cos of 2 pi FCT, where Fc is the carrier frequency and Vc is the peak amplitude of your carrier signal. Mt is your message signal, which has been represented as Vm times of cos of 2 pi. It should be FMT. Message signal frequency is your FMT. Sorry, there is a mistake over here. It has to be FMT. And modulation index MA is equal to Vm upon Vc. It is nothing but the ratio of peak amplitude of your message signal to the peak amplitude of your carrier signal. So now if we consider that if a modulating signal or message signal, instead of containing single frequency component, it will going to contain three frequency components, which whose frequencies are your FM1, FM2 and FM3, and the peak amplitude associated with those frequency components are your Vm1, Vm2 and Vm3 respectively. Then the amplitude modulated signal can be given as, from the past expression we can simply have to put all those values. Then we're going to have is this composite amplitude modulated waveform signal would have been given as Vc cos of 2 pi FCT, which is nothing but your carrier component, plus m1 times of Vc over 2 cos of 2 pi Fc plus Fm1t plus m1 Vc upon 2 cos of 2 pi Fc minus Fm1t. So this is the upper sideband component associated with this FM1 frequency component, and this is lower sideband frequency component associated with this FM1 frequency component. And similarly, we're going to have two another sidebands also, which are associated with your FM2 and FM3, which would have been given as m2 times of Vc by 2 cos of 2 pi Fc plus Fm2t plus m2 Vc upon 2 cos of 2 pi Fc minus Fm2t. Similarly, for third frequency component, that is your F3, will be having upper sideband frequency component as your cos of 2 pi Fc plus Fm3t, and the amplitude associated with it is your m3 times of Vc by 2 plus m3 times of Vc by 2 cos of 2 pi Fc minus Fm3t. This is basically showing the lower sideband frequency component associated with your Fm3 frequency component, and this is its amplitude. So now this particular figure is showing the how frequency spectrum of composite information signal will going to looks like. So from our past expression, we have seen that we'll be having this 7 frequency component. One is nothing but your carrier frequency, which is nothing but your VC times of cos of 2 pi FCT. This is the upper sideband frequency component associated with your frequency component FM1. This is upper sideband frequency component associated with your FM2. This is your third upper sideband frequency component associated with your frequency component FM3. And similarly, this is basically showing the lower sideband frequency component associated with your first frequency component, that is your FM1. This is for your FM2 and this is for your FM3. So this figure is basically showing the spectrum of this composite AM modulated signal. So in general, how do we going to calculate the modulation index for this complex information or composite information signal? That is when your message signal will going to contain multiple frequency component. So whenever several frequency simultaneously amplitude modulated a carrier, the combined coefficient of modulation would have been defined as MT is the composite or total modulation index, that will be equal to under root times of M1 square plus M2 square plus M3 square up to Mn square, if we are considering that there are n number of frequency components available in your composite message signal. Whereas this your M1, M2, M3 are your individual modulation indexes associated with your multiple frequency components. So here this MT is your total modulation index or coefficient of the modulation. So M1, M2 up to Mn, these are your modulation index coefficients of the modulation for the input of 1, 2, 3 up to n. This is what we have tried to explain. So just in order to evaluate this value of M1, what we have to do is, this is nothing but it is the ratio of Vm1 divided by Vc. Similarly, for the calculation of M2, what we're going to have is Vm2 divided by Vc. And similarly for up to Mn, we're going to have Vmn divided by Vc. So this is how we're going to evaluate the individual modulation index. So now the power calculation of this composite information signal. So how we're going to calculate or evaluate the power of this composite message signal after amplitude modulation. So the combined coefficient of modulation can be used to determine the total sideband power and transmitted power using this your P of upper sideband total will be equal to P of lower sideband total or composite, that will be equal to PC times of MT square by 4, where this MT is showing the total modulation index that we have defined in our previous slide, that will be equal to under root of M1 square plus M2 square plus M3 square up to Mn square. So total sideband power PSBT will be equal to PC times of MT square by 2, and the relationship, this is a well-known relationship that we have already derived. PT is equal to PC times of 1 plus MT square upon 2, where PT is the total power and PC is the carrier power and this MT is the combined modulation index. So now we will going to discuss some of the numerical problems associated with the discussion that we have done so far in this particular lecture. So the question says that for an AM double sideband full carrier wave with a peak unmodulated carrier voltage Vc is equal to 10 volt Vp, a load resistor of RL is equal to 10 ohm and M is equal to 1, then we have to determine in the first part power of the carrier and the upper as well as the lower sideband, total sideband power and the total power of the modulated wave. So first of all, we need to mention that what is given to us. So what we have given us is Vc is equal to 10 volt. Please keep in mind that it is your Vp. It means we have given as your peak amplitude of your carrier signal. In some books, if it has been written as 10 volts peak to peak, it means it is the value of twice of Vc. Then in order to evaluate the peak carrier power, we need to divide it by 2. Since it has been mentioned as your Vp, so we are taking this, your peak amplitude of a carrier signal would have been given as to your 10 volt. Resistance R is equal to 10 ohm and modulation index M is equal to 1. Then in our first part, what we have to evaluate is power of the carrier and the upper and lower sidebands. So power of the carrier can be evaluated as PC is equal to A by root 2 by R. where A is representing the peak amplitude of that particular electrical signal. So on the similar manner, we can evaluate this. Peak amplitude of your carrier signal would have been given as your 10 volt divided by root 2, since we have to take this RMS value. So this is how we're going to evaluate this RMS value of that particular square divided by R. That will be equal to 100 divided by 2 times of 10. That turns out to be 5. So PC or carrier power would have been evaluated as your 5 watts. So this is your carrier power. Then we have to also calculate this upper sideband and your lower sideband also. So M is also given to us. M is equal to 1, and we know that particular relationship, that PT is equal to PC times of 1 plus M square by 2. So sideband powers can be evaluated as P upper sideband will be equal to P lower sideband, that will be equal to PC times of MA square by 4, that will be equal to 5 times of 1 square by 4, that will be equal to 1.25 watts. So now in the second part, we have to evaluate total sideband power. P sideband power total will be equal to P LSBT plus P USB T, that will be equal to 1.25 plus 1.25, that is 2.5 watts. So now in the third part, we have to calculate total power. PT equal to PC times of 1 plus M square by 2. So on putting the values, what we are left with is your 5 times of 1 plus 1 square by 2, that is 5 times of 3 by 2, that will be equal to 7.5 watts. This is the answer. Hopefully the process might be clear to you. We can also evaluate this total power via adding this carrier power plus sideband powers separately. Then also we're going to get the same answer. You just can verify it out. Fine. So now we're going to discuss another example related to that particular theory. So second problem states that for an AM double sideband 4 carrier transmitter with an unmodulated carrier power PC is equal to 100 watt, that is modulated simultaneously by 3 modulating signals with coefficients of modulation M1 is equal to 0.2, M2 is equal to 0.4 and M3 is equal to 0.3. Then we have to find out what? In the first part, we have to calculate the total coefficient of modulation, upper and lower sideband power, and the total transmitted power. So first of all, we need to write it down, whatever is known to us. So here PC is given to us. PC is equal to 100 watt. M1 is equal to 0.2. M2 is equal to 0.4. M3 is equal to 0.3. So from the theory, total modulation coefficient MT can be evaluated as M1 square plus M2 square plus M3 square. On putting the values, what we have is 0.2 square, that is 0.04, plus 0.4 square, that is 0.16, plus 0.3 square, that is 0.09. So on adding all those stuff, what we are left with is your 0.29. So on calculating this particular thing, what we get is 0.5385. You can calculate that particular calculation. So this is the answer for your first part. Then in the second part, we have to calculate upper and lower sideband powers. So in the second part, we have to evaluate the upper and lower sideband power. So from the theory, P upper sideband total will be equal to P lower sideband total. That will be equal to PC times of MT square by 4. That will be equal to PC is given to us, that is your 100. Then MT is given to us under root of 29. So this 100 will going to get cancelled with this particular thing, and we are left with this your 7.25 watts. And similarly in the third part, we have to evaluate this total power, which would have been given as your PT is equal to PC times of 1 plus MA square upon 2. That will be equal to 100 times of 1 plus under root of 0.29 square by 2. That will be equal to 100 times of 1 plus 0.29 by 2. That will be equal to 100 times of 1 plus 0.145. That will be equal to 114.5 watts. That will be the answer. Please perform this calculation. Hopefully you're going to get the same answer. So I believe that now the process has been clear to you and you are in a state to evaluate all such type of problem. Just in case of any doubt, ask me in the comment section. I'll try to solve them as soon as possible. So these are the references. Thank you very much for your patient hearing.